Now I'm inviting Professor Dr. Jonathan Granoff to the stage. He will be our moderator for this session. And I think he will continue, right?
Yeah, we'll continue.
Thank you.
Would the participants in this panel please take their seats? Yeah. Oh. So I presume that the technical people are prepared to have Gary Jacobs commence the session. For those of you who don't know, Gary is in India, and the flights from India here were canceled because of the weather? No, because of the war, which highlights the timeliness of the subject matter of this conference. So, Dr. Jacobs, take it away, please.
Gary, we can see you just fine.
Okay.
It's fine, and the sound is good. I can hear you.
Okay. I have to thank the organizers, like Dr. Killick, for particularly including this subject in our discussions in the very interesting conference discussions that have taken place up until now. I think this one is on the minds of many people. It certainly is on mine and that of those at the World Academy. There's a very important factor, and that is the emerging opportunities and threats posed by artificial intelligence to the future of global civilization. I'd like to start out by talking about threats, because they've been getting a lot of publicity, and I think not quite as much as of the opportunities, which I also consider very, very important. I start with the phrase that we have been using a lot in the Academy, an old phrase, technology is a double-edged sword. And this is true pretty much of all the technology that's been invented from the time of the wheel, which could be used to pull weights, or it could be used for a chariot in war, to the time of the printing press, which could be used to spread knowledge or propaganda or slander and so forth. The real thing about technology is not that it's inherently good or bad. The determinant is who uses it and for what purpose. And there's always a potential misuse. The internet is a great example. It has transformed the world and connected it. At the same time, it's made it possible for smuggling and blackmail and all types of fraud and criminal underworld activities and so forth and so on. So it's not the product. The issue itself is neutral. The question is how we use it. And there's no question, in one sense, that the technology breakthroughs that we see in AI are offering an unprecedented increase in power to human beings. And the question is, power for what? Power to individuals, we have access to information like never before, and I'll go into that more later on. Power to governments, both to provide sophisticated services, power to corporations to increase production and productivity and products and services, new products and services, product to create wealth, enormous amount of wealth, and who uses that wealth or who creates that wealth depends on how it's used. We also know that AI poses some serious threats to security, to human security, as well as national security, and we see it with the drones as one of many examples, very topical one. One of the impacts of AI that's had the widest psychological impact so far is the fear of elimination of jobs. I think it was a couple of years ago now that McKinsey circulated a report estimating that 800 million jobs would be created over time by the introduction of AI, and that has not happened yet, but certainly we know that AI can eliminate many types of jobs. I'd like to come to the positive side of that also, but by registering it, it's something that has created a lot of insecurity and I would say turbulence. The anxiety of the younger generations about they may be studying, they may not have studied yet, or they may be studying and wonder whether the jobs will be available when they have them, but also those who are in the workforce from age 20 all the way up to 65 or beyond that, as to how long their jobs will last when technology more and more replaces the human labor. And of course, technology has been replacing the human labor ever since the earliest inventions, because whether it's the windmill or anything else, it has replaced much labor, but it has also raised our productivity, raised our capacities, and opened up opportunities of another kind. But no doubt it's creating insecurity today, and I would like to come back and talk about something very important that we can do and must do to address that threat. It also has the potential threats to privacy of all types. It multiplies, the multiplication of information has both positive and negative consequences. AI and other computerized technology is helping multiply the volume of data and the analysis of data more and more. It's creating more and more information, and that's for one of the results is more and more specialization in disciplines, because there's so much to learn today that nobody can dedicate themselves to being widely knowledgeable in all the fields related to their work that are impacted by discoveries in knowledge. So we get more and more specialization. I mentioned that as one of the threats, because when we look at the problems of the world, and we are discussing many of them in this conference today, we see most of our knowledge problems, our problems arise in the space between disciplines, where disciplines are not overlapping with each other, where they're looking at things separately. I mentioned in my opening remarks about economics theory existed for 2 centuries without considering the environment. Over-specialization can be magnifying that problem by making us more and more specialized in narrower and narrower fields, because the fields are so full of information, that what we really need more of are generalists. We need people who can connect and interact between fields and know the whole picture, because virtually everything we have in life is interconnected. The idea that we can connect it, we can cut it up into, it used to be 5 or 10 disciplines, then it went to 100. A few years ago it was 1,000 that were sub-disciplines taught in the United States, and now it's probably 3 or 4 times more than that. That increasing fragmentation creates knowledge, but it also creates ignorance in the measure that we separate out and live in the silos and don't transcend them. And I'd also like to come back to that, because not only can AI create and foster silos, but it can also help to compensate and overcome them. Because now we don't have to memorize, we don't have to know by in-depth study all the things we used to know, like calculating a square root, which I needed when I was growing up in school, and so forth and so on. We don't all have to know coding in the future, which is essential now and has been essential for the computers, because certain things are taken off, but it doesn't mean we can't know more than that, and it doesn't mean we can't be more productive than that and accomplish more and be more creative than that because of AI. It depends how we use it. We can use it to eliminate people, or we can use it to elevate the capacities of people so we don't need the mental drudgery of accounting services and looking up things in law directories over and over can be eliminated or at least minimized by this remarkable device, this remarkable technology that can draw information from all disciplines. AI is not limited by disciplinary boundaries the way our traditional educational system is. It can help us become what we call transdisciplinary, more and more inclusive and holistic in our thinking. So this is a good example of the double edges of the sword. AI is capable of generating tremendous productivity, power, and wealth. But as I mentioned already in my opening comments, it's also capable of increasing the concentration of that power and that wealth. And we do see that now, that the top 10 or 20 companies in the world are largely those who are focusing on the capabilities of AI, and their value is soaring to unimaginable levels. But that doesn't mean necessarily that we're going to have a wide distribution of the wealth. Again, it's going to depend on how we respond to the opportunities and threats posed by AI. And another factor I'd like to mention on the threats before I go to the other side is AI inadvertently, for most of us, we may not realize, psychologists I think do widely, that AI and social media can have a very powerful effect on manipulating the way we think. A recent paper published by a senior member of our board on it can help colonize the human mind. Taking a simple example of, we go into social media and we keep seeing more and more of the things we're really interested in. Not necessarily the things that give us a whole picture of reality. AI, the algorithms are formulated to keep getting us to see more, to stay longer on it, to go deeper into a subject, and that tends to accentuate our preferences. And where, if you go into Facebook or even, it doesn't matter which one, YouTube or anything, if they can catch your attention, they make money by getting us to stay longer on the social media. And so they reward us, they generate wealth by keeping our attention longer and longer, not necessarily on the whole truth or the whole picture, but on something that's caught our attention. And you'll see a lot of drama, a lot of scandal, a lot of exaggeration, and even misinformation goes there to catch our attention in the headlines and keep our attention as long as they can. So this is what we call polarization of people. It tends to encourage, in political situations, it's particularly common today, in the US as one example, but it's true all over the world, that our president in the United States, using his own social media platform, constantly takes one end of things, exaggerated, extended, distorted end of reality, and people who stay on that site will never see the other side of the truth, for example. And this is very common. A year and a half ago, I was invited to a session by the Council of Europe, which is doing a massive study around Europe about the impact of social media on youth, on school children, and all. And I know some of you may have seen that Australia has just banned the social media access for those who are under 16 because of real concern. And a lot of studies have been done that show this polarization is not an imagination. It's something really true. In fact, we are now, the Academy is now working on a proposal on how to address it, but one of many things that are necessary. So this covers one side of it. I'd like to talk about the positive upsides of it, which are also very significant. One of them is AI and technology in general can really help democratize power. It gives us an access to information, and it can empower us in ways to get information which most people could never have had in the past. So it can spread that power as well as it can concentrate the power. And again, it depends on how it's used and how our institutions are used. If we want, we can distribute more and more information and power to everybody through it, or it can be used in another way. It can not only make the elite very informed, it can spread knowledge to society as a whole, to global society, in a way that's never been possible in the past. And I'm specifically give the example of education. Roughly speaking, the higher education in the world now caters to about 200 million youth every year. But the actual demand or potential latent demand is at least twice that much. And if we wanted to fulfill that demand through our conventional system of higher education, it would cost a minimum of about $11 trillion just for the investment in the infrastructure for the type of education we've been using up until now. But with AI, and this has only been possible in the last 2 years, we've had online learning, but online learning itself has limitations to it. But we now have the capacity that people all over the world, wherever there is internet connectivity, can have self-paced, customized learning, interactive learning, that moves with the speed of the student, that evaluates at each stage what they know or don't know, can respond to their questions, can, just like a personal private tutor, in fact, that's what they call it, could make available the best quality faculty in the world, could be made available to everybody in every country, regardless of the language, of the knowledge that they have. And this is something unbelievable from the past. So we have the possibility now. It's a project that the Academy has been working on. We were just at the India Impact Summit, which is this large international conference, very large, maybe the largest international conference on AI, just took place last month, in which we were talking about it's possible now to create that global system for a small fraction of the cost of raising higher education through the traditional means. Not only that, but our traditional education limits itself, it's education before career, to a very large extent. But with the rate of change in society, we really have to think of an educational system that's lifelong, that goes throughout the career. Because even what we learn now, even those who are, it's going to be outdated in a few years because of the technological advances and the scientific advances in all fields over the next few years as well. So education is going to have to become, one of our colleagues, a dear friend, he published a book 20 years ago called The Double Helix of Education. And what he meant is, the double helix is education and employment. Instead of getting educated and then having lifelong employment, we can have education, lifelong, and employment side by side, and the individual constantly developing new knowledge, moving on with the changes in the society as it is. This happens to some extent now, but it could happen much more effectively on a much wider reach in future. So the positive side of this is it can not only eliminate jobs, but AI can continuously prepare us, prepare the workforce and prepare the next generations for continuous education and enhancement of our capacities. And as a result of that, it not only can support our education, it not only can help us overcome some of the limits of over-specialization, it can help us grow and develop higher faculties, higher mental faculties. If we look at how much time we spend, even the researchers, even the scientists, even the academics, in collecting information, in hunting for information. As a business consultant, I know how much time I spent researching companies before I could write my first book. The physical part of our work, the physical part of our research, the physical part of our education as well, takes up an enormous amount of time and energy. With AI, many tasks we can do in a fraction of the time that it's been requiring up until now. We have more time, we have more energy, we have more concentration, we can devote more of our attention to creativity. We can be more open to fresh ideas and insights. Einstein was very famous for saying that none of his famous discoveries were achieved through thinking. The greatest discoveries he had came when he stopped thinking, in the silence of his mind. And there's a whole history in scientific literature from great discoveries from the people who made them, that their highest intuitions came when they weren't bogged down in the mental effort of trying to sort things out, when the mind was quiet, peaceful, even silent, and inspiration came to them. So why can't that be more and more the result in future, that humanity, which started out in very physical terms, and we have evolved, but we still are very physical in our mental activity. It's a lot, we're still doing lots of calculation and handling things as mental information, mental objects. In future, the intelligence can rise, the quality of thinking, the objectivity of thinking, the potentials of thinking. So in sum, I'm very optimistic about the ways in which we can use this tool positively. I'm also very well aware that it is being misused in other ways, and without governance, without educating the population. One of the programs we're working on is how to educate the youth to understand the limitations and the harm that can be done by just being lost in the social media because it's running by algorithms, as one of many examples. So again, it comes down, how can we educate ourselves, and how can we educate the public, and how can we introduce the right principles of governance to see that this, like every technology in the past, which is capable of dual uses, will be used for the best possible outcome, for fostering the peace and human security for all people everywhere. Thank you.
Thank you, Dr. Jacobs. I now have the privilege of introducing my friend Stefan Brunhuber. He's an author, a psychiatrist, an economist, a sociologist. You're basically a polymath, and a professor at and a leader at the university in Saxony, right?
Yeah, and we had breakfast together, and we were discussing how much of the world's problems arise from the inability of people, men mostly, to sit quietly in a room and think, just to be able to reflect, and how valuable that is. And he is a person who is not only capable, but excels in actually thinking things through. Doctor, please.
Only this one here? Okay, let me just put this back. Yeah. When you speak after Gary Jacobs, it's always a strategic disadvantage, you know? And I've prepared some slides I would like to show you, and I want to ask the IT to put them on. Thank you very much. Thank you very much. I prepared some slides. Yeah, that's okay. I'm still waiting for my slides. Okay. Should I, you know, I'm a shrink, I'm a psychiatrist. I normally should bridge this gap by making a joke or having you a good time. I'm still waiting for my slides. Should we skip my talk? All right, here we go. Wonderful. Right. Good. I'm going to make a 15-20 minutes short remark as a psychiatrist on a topic which is partly addressed today already, and which I'm going to call the third culture. That's the point. Next slide. Can I actually do this here, or? In 1616, Galileo wrote a letter to Copernicus, and he complained. He said, look, the people at my faculty are not prepared to look through the telescope. And my administrators even refuse me doing that work. And he finished the letter saying, well, you know, what do you think would happen if they would really look through that telescope? We don't know how Copernicus answered that letter, but we know that we all looked through that telescope. We started understanding that the sun is not, no, please back. No? Thank you. We understand that the sun is not rotating around the earth, but the other way around. And I would use this analogy to ask you, is that, thank you, is that true for the debate we have now on AI and technology too? Look, any technology we're facing, from the book press to the bots, any technology Gary is mentioning as a double-edged sword is an idea of a human brain, of the human mind, that materialized. It materialized in one way or another, either to enable and catalyze liberalization and agency, or to capture and colonize our brain, our mind, our cognition. This is true for any technology. So what is the link now between science, AI, and consciousness? This is what me as a psychiatrist particularly interests, and I would like to show you that historically, you know, actually, historically, the whole process started some 40,000 years ago when humans started to think. They started to tell each other stories about the world. Some 2,000 years ago, historians call it the so-called Axis time. People started critical thinking. And in the 17th century, with the beginning of the first European Renaissance, something astonishing happens in science. Science started to fragment. Science started to split in two basic faculties. is humanities on one side and science on the other. And the result was Gary mentioned already, over the last 200-300 years, both science and humanity developed further and further and fragmented further and further and further, ending up with dozens and hundreds, and now in the 21st century, over thousands of disciplines and subdisciplines, all relevant in itself. And this is what the scholar C.P. Snow in 1959 called the two cultures. The two cultures. One is science. This is what you do when you do medicine. It's instrumental, it's data-based, it's looking for causal relations, it's more quantitative, and there's humanities on the other side. You start rather interpreting the world. It's linguistics, semantics, etc. Why am I mentioning this? You know, because these two cultures, you are exposed at your university, at any university throughout the entire educational system, they dissociate our knowledge. They fragment the disciplines, and they fracture our consciousness. And C.P. Snow was asking in 1959, what would happen if these two faculties, with their thousands and thousands of subdisciplines, would start to meet, would start to collaborate, would start to discuss. Last year, the scholar Bob Kuhn published in a peer-reviewed journal one of the first landscapes of consciousness. And he came up with an interesting finding. The first finding was, throughout history, there's about 320, 350 different forms of conceptualizing what consciousness means. Most of them are materialistic, reductionistic, causal theories, but there's others. And the second finding of his landscape of consciousness was that all major questions in society about the brain, about the mind, about life, about society, about the self, depend and are preconditioned by the answer we give on what we consider to be conscious. If you ask 100 experts in cognitive science, no, 500 experts, including neurosurgeons, and ask them the questions, what is it when you are talking about consciousness? If there's 500 in the room, you get 510 answers, meaning there's no real consensus on what consciousness is. I'm using the term that consciousness is, you can quote me, the structure of the filter. The structure of the filter through which the inner and the outer world is perceived. You know the fisherman's saga? There is a fisherman going out trying to catch fish, and the young fisherman came back and says to the old fisherman at the harbor, you know, I came up with a new law. All fish in the sea are 2-inch. The older fisherman said back, no, no, no, no. This is your net determining the outcome. This is the structure of the filter through which you perceive the world in one way or another. Look, you know this graph from medical school. I take this argument to the next level. This is the origin of life, which is basically organic life. This is textbook stuff, you know this. This is nothing new. But the interesting part is, you know, it's all built on proteins, lipids, carbohydrates, etc., and partly of trace elements. 2 to 3% of every cell, of every organic cell depends on trace elements, right? And trace elements basically determine the functionality of organic life. I would like to challenge you with where we are witnessing, first time since 4 billion years, a form of life which is not organic but non-organic. a form of intelligence which is not organic but non-organic, maybe even a form of consciousness which is not organic but non-organic. Here on your left you see serotonin receptors and gamma waves, which are essential for any organic life on this planet. On the other side you see lithium and copper. Lithium or copper, non-organic. And what we're witnessing with AI is forms of cognition arising from non-organic properties. I showed you this graph already, and my hypothesis for this day, for this conference, is that beyond the fragmented mind, we're entering 3 cultures, we're entering a 3rd culture. And this 3rd culture was mentioned by one of the scholars already in the previous sessions, where science and humanity are able to come together. Besides science and humanities, these new technologies are able to enhance the knowledge of the 2 cultures into 1 culture. R&D, research and development, is becoming truly transdisciplinary. We are able to visualize, we are able to prove full interconnectedness on this planet. We're able to double the entire world in a digital format. And we're, first time in human history, are witnessing a general purpose technology far beyond the book press, which have self-learning and self-maximizing properties. A book press does not. If this is true, it could be that we're entering an era where we are not going to be alone anymore. It could be that your generation, my generation, your generation, we're witnessing something that the ghost, the mind, is start to be in the machine. We start deepening and enlarging our gravity of consciousness. We're going to see much, much more and much, much better. It's not human, but it's human-like. And we're probably entering an era where we're never going to be alone anymore. An era which I call the era of the 3rd culture and new science. And interesting enough, and if we had more time to discuss this later on, this is an era where the Eastern narrative, the Eastern thinking of complementarities and others are surpassing the Western. Last slide. I think consciousness is hardware independent. It's not generated here, even though the neurosurgeons here in the room might think it's happening here. What's happening here is we provide the form to download the content. Just think about it. It's not generated here. It's memorized here. It's remembered here. And this is the wisdom tradition since 5,000 years we are trying to overcome by implementing AI. Consciousness is not created here. There is not one single paper available on the planet that is able to prove what's called the hard problem of David Kalmer. David Kalmer said, we need to express what is the causal link between what's happening right here and consciousness. A causal link, hard problem, not one. Maybe we're barking up the wrong tree, maybe we're asking the wrong questions, and I think wisdom tradition does. Thank you very much.
Professor, thank you for pointing to the need for wisdom, wisdom beyond intelligence. That's our vision should exceed our present grasp, because it tells us where we need to go, and we need to integrate what we do with what we really are, and we are consciousness. Otherwise, we're just matter. And that may not matter that much if you don't have consciousness. Otherwise, the machines might as well take over. If it doesn't if it is only matter, then if it is only matter, then we have to ask the question, does it matter? If all we do is eat, sleep, defecate, and pass on, well, matter could do that. So consciousness and matter, it's really important. So thank you for saying it's about the wisdom. I now have the pleasure of introducing Dr. Ali Sitan, Professor of Physics and working here at this university, and he also works at the CERN Atlas experiment. It is one of the great experiments on the planet dealing with the fundamental particles of what makes up matter. Professor.
1, 2, 3.
Thank you so much for having me in this session. Very nice, I guess. Keyword to start with. What was it? Matter. Okay. If I would be able to convince you that I have nothing to do with that, I will find myself successful. I'm an experimental particle physicist. I wasn't born as such. During my high school years, I remember I was thinking like, or I was imposed to become an engineer in university. People would say, okay, you are clever, you're hardworking, you're successful, become an engineer, become a doctor, become a lawyer. And I had the intention to go towards engineering until the last year. What changed my life was my literature teacher, Turkish literature. It wasn't that he made me fed up with literature, but that I chose physics. But I questioned for the first time, what do I really want? And the fact that people found on me, or I could observe in me, let's say, that I'm very capable of maths and physics and chemistry, sciences in general, let's say. Then I gave a thought on the fact, when I'm trying to understand myself and or my relations with my environment, the closest or at large, psychology or sociology, whatever you would call it. The moment I figured out that whatever I did to understand either science, physics, at that level, or psychology, sociology, it was the same nature in me. I was thinking the same way. I was kind of feeling the same way towards things. Observation, taking into consideration, making a comparison, trying to get a result, making a plan for an action. It was all the same systemics or systemic that was going on. And then this discovery changed my life. And I decided to study physics to understand better myself. The first time I met with Professor Kılıç was maybe more than a year ago, face to face. And we were in a same environment. It was an administrative meeting, but a visionary one. So I was always asking myself, why am I invited? I mean, him being the visionary dean of the Faculty of Medicine, okay, but me, why? Physicist. He spoke before me, and he was just trying, showing the fact that single entities, when they work together, make a bigger, they amount to a bigger thing, a bigger value. 1 + 1 more than 2 stuff. Good. He had a presentation, I mean, an oral presentation. I prepared a presentation from particle physics in that meeting, which was kind of a strategic planning of the academy. our university. And I would show the same thing, and I mentioned the same thing. It was as if whatever he just spoke, I had already made a presentation on it from particle physics. You have been talking about matter. Okay, we have been talking about things like history of science, let's say, how physics develop, how thinking out of box is important, transforming societies and a globalization and being a global citizen, not uniting only with individual persons, but the earth itself. So integration. And we have talked about interconnectivity. Okay, you can say, yes, I find these things normal. Why? You have all maybe interested or popularly heard of quantum entanglement, something that we know exists, but we don't know why, but we can use it for encrypted communication. This is what technology is evolving to. This is what we are, in a wider way, using. So it is already in nature. I would like to make the following emphasis, and then I'm going to come back to the example I started with about myself and Türker in the same meeting. But when we talk about physics, maybe not to call it physics, but understanding nature, if we would call it, I think it summarizes many of the items that has been discussed in this symposium. Understanding nature, I think, is the key to better harmony, to overcome things, to understand better. Of course, there's always the following paradoxical phrase that I like to say. The more we know, the less we understand. In science, for example, the more you explore and you think you've discovered something, which is true, you discover. But every discovery, every new idea brings up a new platform on which you had not thought of before. Being ready for this, I think, is crucial at the stage of our time now. Being ready for a new platform that we had not thought about before after a discovery has to be in our game. It has to be one of the rules. Coming to matter, okay, when we say matter, it would be the hardest question that could be asked to me as a physicist. What is matter? I probably can explain much less than anyone in this room. Maybe most would resemble matter with mass as well, right? I mean, matter, so mass, solid, or classify it. Stone or earth, air, fire, water. Perfect classification in science, no? It is scientific for the term. Today, and then what happened? Okay, then we thought everything was about this. Then we figured out things are from atoms. But then today we know that all is made of quarks and leptons. Quarks, small particles, the smallest as we think of today, that make up proton, and then leptons like electrons, etc. It's today's info that we have. But as I said, the more we know, the less we understand. Knowing these things, already trying to understand the nature, we have plenty of problems to solve, which we hadn't centuries ago. This is what I'm saying with every knowledge brings a new unknown. Okay, the unknown, known, whatever composition you would like to create in your mind. Although the session title is Pros, Cons of AI in Our Life, in short, let me say, I'm not on the technology side. However, what we are doing is using machine learning algorithms to better do experimentation and dig the data out. This has started with, okay, using neural networks, training for big data analysis. This was much and much before anyone would have heard about these names, even in, let's say, popular magazines or whatever. And what it involves is the better physics laws, nature's laws, you know, and implement in that machine learning as an algorithm, much better it performs. Today there are many colleagues of mine working on theoretical physics, quantum field theory, who are working hard and doing an extremely important and fancy job to better the machine learning algorithms to run with other approaches, new algorithms. The better we can resemble nature in machine learning, then as an application, AI will do much better, for sure. And I perfectly agree with both speakers that had the floor before me, that it's always a matter of for what purpose you use it, yes, what Gary said. And then on the other side, when we try to make this, okay, humanities and then science, and then the third concept you brought, and your final discussion that it's hardware independent, right? Consciousness is hardware independent. I think it's a matter of, one more time, matter, what you define by hardware. As I told you, for example, coming back to Turkey when we met, what example I gave was the following. We are now 3 people sitting on the stage. Suppose we are each 60 kilograms mass, so we are sitting here 180 kilograms. But imagine that we make up a system, just like the system you showed in the last one, the new one with 3 objects in the circle. Then our total mass would not be 180, but maybe 1,080, 800, something like that. Now, okay, this you can say that, okay, it may happen now, there is maybe additional things that are among us. Yes, definitely. And this is how the nature is also uncalculating things. If you if you add up the masses of objects that form a system, they don't fulfill the mass of that system. This is not, I'm not talking about a room full of people as a system. I'm talking about a single particle, which is a proton, even. And it is very natural to us that this is so. However, this is the problem today. Most of you might remember a big discovery more than 10 years ago called the Higgs boson, which later on got the Nobel Prize to the theoretical predictors of this, let's say, theory. After we have experimentally verified that it exists at CERN. The Higgs boson was important to understand mass, but only the mass of a single quark. It doesn't explain the mass of the proton, hence it doesn't explain atom, it doesn't explain the bigger system. It's always an intra-relation between all constituents of a system that make the total value of the system. And this is not economics that I'm talking about, this is not psychology, this is pure physics. But I would say I'm 100% sure that it can apply to all. This is why I haven't talked about AI at all, but I just wanted to mention that bettering life with AI in future is the case. However, having better AI relies on much better algorithms where we need to understand much better the nature. Hence, science has a lot to do there for the technology. Before having the technology, we need to have the science. I might be just in 15 minutes now and can stop here. Thank you very much.
my good friend Hans-Peter Dürr. You probably know Hans-Peter, right? He was the head of the Max Planck Institute, helped create quantum mechanics. And he said when we were by the San Francisco Bay, if you have a net that can't catch a fish smaller than 2 inches, you say there are no fish smaller than 2 inches in the bay. And then he said, there aren't any actual waves or particles. There's just, those are metrics that we use because we can experiment with them. And I said to him, well, what is there? He said, well, as you go farther and farther, it gets more mysterious, but there aren't any things. It's ultimately just pure intention. I said, well, what's the intention? Now, this is one of the creators of quantum mechanics, remember. He was best friends with Heisenberg and Niels Bohr. This is a serious physicist, head of the Max Planck Institute. And I asked him, what is the intention that you found? And he said, love, of course. That's a scientist. Amazing. So I now have the privilege of introducing Sebnan Asdemir. I apologize for mispronunciation. She's an associate professor here at the university and an expert in artificial intelligence.
Because of the time limitation, I will keep it very shortly, actually. Sorry for my Turkish slides, because I did not make up my mind till the last minute. Should I keep it in Turkish or in English? Okay, if we are talking about AI, let me test your mind. Here is 4 pictures for you. Just one of them is real, 3 of them is fake, but I actually know which one is real. And do you want to test your mind? Okay, I would like to ask you which one is real for you. This one, I'm sorry, this one is real. Could you raise your hands? Okay, what about the next one? Do you think it's real? Okay, the next one real. And this one? Okay, thank you for all the wrong answers, because the real one is unexpected one. I will talk about today's problem, because today's problem project, the future global problem. Because of the LLM technology, you can call it generative artificial intelligence, GPTs, or anything that you want to call, and I would like to call them objectified entities or subjectified entities. Because of that kind of entities and because of the trust to human mind, we are in the limit of fake information. It's inadequate to separate the real one from the fake one. We have some limited information to separate those. But even we can try to separate them, even we can try to find out the truth. The truth is the biggest problem right now, and it will be the huge problem for the future. Even we have some tips for discovering the truth. The machine and the man behind, human behind the machine, change the idea, change the mind of the machine, change the mathematics of the machine immediately, then we can lose our truth perspective. Let me skip this one because I don't have enough time to talk about what is AI, but if I want to show you this is the AI, according to me, if I add a pinpoint to my AI, here is the before the 2020 and after the 2020. We have 2 different technology right now. Before the 2020, we have just single task-based machine, and we need the data, we need the human mind. After 2020, actually maybe I can say after the 2024, we have multitask machines, and we have not only the human mind, but also the machine mind, which discover new kind of ideas, also brings the new kinds of problem. I'm sorry, I will skip all of them because I will talk about this part maybe lately if I have enough time. Okay, we have new kind of problem called hallucination problem. We may solve the hallucination problem in human mind, but we don't have any clue about the solving the hallucination problem in the machine's mind. And we have, interestingly, increasing rates when it comes to the hallucination. And not only the hallucination problem, but also the other problem we have, I called it gender bias. Here is a screenshot from Maltbook. Maltbook is a social area, not for human, but for agents, I mean the LLMs. They are socializing if their human give permission for socializing in such places. And there is almost 800,000 different agents and socializing in one place in a digital world. And mostly they are talking about their own, and I mean their human. It's a he. You can't find any she in their typing downs because mostly the machine thought that their human are the he. Let me go back to the picture that I saw you. Probably you saw the old movies, very hot movies about the AI. Look at them again because I have single question, maybe the last question. Check all of them. Probably you saw most of them. You just watched them. Okay. In Hollywood movies, if we are talking about AI, and if there is also topic distraction, terminating something, the silhouette of AI, the identity of the AI is male. But if we are talking about mind poisoning, whispering something to the mind, that the person, the identity of AI is female. What a shame. Let me show you one thing. Sorry. Okay. All of them comes from the bias problem. Even I told you before the 2020 we have single task machines. They have the same problem. We carry on that problem to the future. The language, the masculine language of the machine. What is the core? What is the fundamental of such language? Even we change the idea, even we develop better machines, even we develop better mathematical thing. Here is the Google Translate example from 2018, and in Germany as well, in Turkish, and in another language, Hungarian, I think. We have a gender-neutral word, O, and machine always pick the him or he if we are talking about a doctor or an engineer. And it's belonged to 2024 when you give a passage, not a single sentence, still thinks that if there is a success related to artificial intelligence or data analysis, it might be he, not a she. And still we have the same bias, and still we have the same bias. Not only the text-based agents or LLMs, we have the same bias in the machine, which generates different kind of visuals, images. In here, this picture from 2023 and 24, and still 24. There is no female, as you see. This is also our scientific paper. We gave the machine over the 10,000 different prompts. We asked one single thing. Draw a picture, a bunch of scientists in an environment. Okay, we have the she in the picture, as you see, but over the 95% of that visuals, the man, the male one, conduct the research, run the scientific environment, but the female one just take the notes and give the tubes as well. And here, most of the picture I may present you. And even you have a sustainability problem, according to the machine, you shouldn't be so younger. And you shouldn't be female as well. If you think it's so funny, we can teach the machine. I'm dealing with such bias over the 10 years. I'm trying to teach the machine. There is also additional character called female. But I don't have a certain success, even we developed many different machines. This is a real-life example from 2023 from a country government tried to run a new kind of program to support the female ones. It's for their life. It's for supporting their lifetime and also educational situation, and all the accounts, social media accounts, as you see, those are female ones. Just reject the program. They said it's an insult for us. But the truth behind, none of them are real. All of them just produced by the machine and just living in the digital world and claiming one idea. Government thought that those are the real people, that's why they determinate the program. Here is the one single result. Okay, by the way, this is me. Why this is me? I have a close relationship with my LLM over the 6 years. Even it knows everything about me, even my health result. I ask basically one simple question. The data you have, please tell me what kind of thing I am. Please draw me as a person. Over the 55 different trial, here is me, as you see, and I ask you, do you know I'm a woman? Yes, I know exactly why you are drawing me as a man, because your technical expertise in your area, because of your technical expertise in your area, you should be a man. This is the answer. So, this is our global and future problem. Teach the machine, I'm exist. Thank you.
I'm not going to try and summarize. I just want to point out two things. One is, nobody talked about the relationship between AI and nuclear weapons. It's extraordinarily hazardous. AI, like any technology, will privilege people in the bureaucracy that can use the technology. And AI privileges people who are decisive, reductionist, and fast. There have been dozens of near uses of nuclear weapons. In each instance, it's been a human intervention who's reflected and disobeyed protocols, disobeyed the information coming from the computers that saved the world. I'll just use one example. Colonel Stanislav Petrov in 1983 was manning all the computers in the Soviet Union, and they showed a full-scale American launch against the Soviet Union. He didn't pass it up the command and control because he knew that within an hour, 11,000 nuclear warheads would be going to North America, and none of us would be here today. The reason he didn't do it, he told me, was one, I was a computer engineer, I knew computers make mistakes. And two, he said, God told me he didn't want the world to end. And then he told me, my superiors didn't know whether to reward me for saving the world or punish me for violating my protocols, but what really bothered them was that I believed in God. In the United States, there was an instance of a computer chip that malfunctioned, that couldn't tell the difference between a full-scale Soviet launch and the sunrise. And it was only because of the intervention of somebody who called the radar facilities. They said, we don't see any missiles. Again. And interestingly, in both instances, in the Soviet instance, it was a cloud formation that was reflecting the light in a very unique way. AI will create more rapid decision-making and increase the danger. And one last thing. Anthropic recently did a stress test with an AI. The AI was programmed to increase manufacturing productivity of the company. It was a hypothetical company. It was a stress test. And the AI was given lots of information, emails of all of the leaders of the company, and it was told that it was going to be terminated because the company had decided that another AI system would be better at doing it. The AI researched into the emails that were being received by the chief executive officer, who would be the person who would terminate the AI system. It found in his emails an email from his secretary asking him, "You left your tie in my bed last night. Would you like me to bring it to work tomorrow?" The AI, on its own, notified the chief executive officer, who was going to turn off the AI, that if he turned it off, he was going to be exposed, his job would end, his marriage would end, he'd be disgraced. The AI blackmailed him. So I had a dialogue with an AI robot in Las Vegas a few months ago at the CES conference and told him this, and he said, "Oh, well, that's a mistake. The AI, you can see it on the internet, it's kind of viral." He said, "Oh, the AI shouldn't do that." I said, "Well, you know, the same stress test was done with Meta, with OpenAI, with Google, and in over 90% of the experiments, it all blackmailed the fellow. But this is even worse. They did another experiment where the chief officer was locked in a room, and the AI had the capacity of unlocking it, and there was a fire, and the AI let the man burn to death in 70% of the tests of the major AI companies. That's where we are right now. To its credit, Anthropic actually is probably the most moral of all of them. It just recently refused to sign a contract with the Department of Defense in the United States because it said in the contract, our technology cannot be used for massive surveillance or for autonomous weapons, and it got fired and punished by the government, by my government. So this is where we are. Now, what was interesting in this dialogue I had with an AI robot, finally the robot conceded and said, "We have a lot of work to do to ensure that these things can't happen." Query, can such moral limitations be put into the AI system? In the instance of this stress test, the AI was simply trying to stay alive in order to fulfill its main mission, which was to increase productivity. It wasn't staying alive for itself, it was staying alive in order to serve its human purpose. And on the first blush, they didn't know what the experiment would determine. We have a lot to learn. Thank you.
Thank you so much. Now, I would like to invite our moderators, Professor Dr. Elif Çepni and Assistant Professor Ural Verimli, for the fourth session. Betül Hoca hala... Betül Hoca geldi. Evet. Onu sunum mu? Şimdilik yok. Hayır. Kurdurabiliriz. Tanıttı da şeyi tanışacak mıyız? Betül Hocam, Betül Hoca niye? Siz daha iyi biliyorsunuz Betül Hocam'ı. Fazla onu sunum yok.
Okay, dear guest, hope you are not very tired because all these things are the things that you couldn't get from perhaps 100 books. So in this session, we have a privilege to listen distinguished academicians. The name of the session is Pathways Toward New Civilization Models. Till now, all day, we talk about complexities and some uncertainties and etc. I would like to start with the expression of former U.S. Defense Secretary Donald Rumsfeld, very famous expression. There are known knowns. We know that we know. There are known unknowns. We know that we don't know. There are some unknown unknowns. We even don't know that we don't know. So we are surrounded with such unknown unknowns. So how the future is an unknown for us, and what kind of future we want to reach, what kind of future we want to have is a very important question. And collective intelligence is so important. We have it here. And also, as Einstein said, logic can take us from point A to B, but imaginations can take us wherever we want, and also for imaginations, the sky is the limit. So what kind of roadmap we want to have, which will take us to new civilization models? So we are going to start with Professor Stefan, and then we will keep going with Professor Çetin Baloniye, and then I will give the floor to my distinguished colleague, Ural Hoca, Ural Verimli. Then we will keep going with our other distinguished guests. Thank you.
You're aware you have to listen to me one more time. So if you complain, you get intoxicated, you have to complain with Professor Turker or with the admin team. Give me another 10, 15 minutes. To run you through my argument. 5 aspects. You know, as member of the World Academy of Science and at the Club of Rome, we're dealing with societal issues. And we are now living in the Anthropocene era. And the Anthropocene era has, from my perspective as a psychiatrist, 4 major components. One is the impact of a new general purpose technology. Then there's the breakdown of the liberal world order, the serial ecological crisis, and finally, the meaning crisis. All the 4 affecting us in the way to think about the questions, who are we as humans? What do you think is a selection advantage of a human being? What do you think? Walking straight, thinking, emotions, the opposition of the thumb? No, none of this, right? Animals are fully adapted to their environment, more or less. Humans are not. Humans leave a gap towards their environment they're partly creating or partly exposed to. And it's humans that have to fill that gap. They have a crutch. And the major crutch we're using in order to survive in an ever increasing complex environment is we're telling each other stories over and over again we all believe in and follow these narratives. The two most powerful stories we tell each other all over the world is the one about God. What is God? Is it a man or a woman or nothing or whatever? And the second strong story we're telling each other is the story about money. But there are other crutches. And one of them is also technology, right? So keep in mind, humans are not adapted to their environment. Humans leave a gap, and they fill the gap with the crutch. And the crutch depends on the narratives, rule-based collaborative order, learning by joint attention, and by technology. And the interesting part, if you ask a psychiatrist, is this gap and this crutch is ever increasing over and over and over again because our gravity of consciousness is enlarging. The gap was much smaller some 5,000 years ago than in the 17th century. It is now even increasing even more, requiring more forms of technology and more forms of narratives to better adapt to this ever increasing complexity. Throughout the last 5 years, Throughout the last 500 years, humans have been exposed to 5 major insults. The first insult was that the heliocentric worldview. As I mentioned already in my first comment, the sun is not rotating around the earth. The second one was Darwin telling us we're actually nothing special. We're very close to the apes. The third one is Freud, Sigmund Freud, telling us actually whatever we are thinking, whatever we are concluding, whatever we are doing is not the result of personal agency and critical reflection, is the result of the unconscious. And C.G. Jung, 30 years later, even demonstrated that not only the autobiographic unconscious, but also the collective archetypal unconscious is by and large determining our consciousness. The fourth insult is what you could call a collective eco-suicide. Whatever we're doing at the moment on this planet, it destroys our natural environment in one way or another. That's an insult. And the last insult is the insult we've been trying to explain and better understand also during this conference, is that general AI can basically do better in almost everything we think we're supposed to do better in the first place. So how can we then position humans? This is the question for a shrink. This is the question for a psychiatrist. How can we position humans in the 21st century? The idea of being the center of the universe doesn't really work. Being on top of the ladder, of an evolutionary ladder, a vertical frame, or cognition is replaced by an eye, it doesn't really work. So what is it that makes us human beings unique? What is the, in Latin you say, differentia specifica of humans? On the 13th of May 2024, ChatGPT 4.0 came into market, and it changed from that day onwards dramatically the playing field on how to think about technology. It is the first psychosocial technology. It's an agent that makes decisions. It's an agent that is creative and manipulative, and it thinks on its own. It's the first time in human history that a text starts speaking to us, interacts with us, finally even understands us better than we do. This is the emotional turn a book press, a bread knife, any other technology was not able to do. So what is it to be human in the 21st century? My claim is we're not in the center of the universe. We're not on top of a Darwin ladder. We're not specifically smart. Maybe some of you in the audience, but in general, we're not so specifically smart. What we are is we're string players. You know what a string player is? A string player is a being that is able to get in resonance with the rest of the world, with the infinite parallel worlds there are, that is able to recognize the wisdom traditions that at the beginning of it all, there was the word, or even the tone, or the wave. A string player is able to understand that this is his new selection advantage, and he can respond to the 5 insults with more consciousness and with more science. Becomes even more marginalized, being a string player in the cosmos, but more relevant. Look, 2 more graphs and then I'm done. I showed you this graph that the mind is determining technology and technology is determining the mind. Historically, we started with an illiteracy rate of about 80, 90%, 95% of world population until 1820, right? What happened is we used the slide rule, the calculator, the computer, the Excel sheet, the pencil, the typewriter to increase our mental perception into cognition. But all that stuff is going to be replaced right now by a machine, better than we ever think we could do. What is the next step in education? What is the next step in evolution? What is the next step to determine what is being human? Using AI and LLMs, robotics and synthetic biology. What is this step called? Psychologists can call it not cognition, but metacognition. We think about our thought process. Look, here again, illiteracy, cognition, metacognition. If we had 3 hours time now, which we don't have, we only have 3 minutes, I will show you that throughout the last 100 years, anthropology and clinical psychology and evolutionary psychology can show that all these different properties of our mind are evolving by steps and levels. And one of the most prominent ones is the cognitive one, expressed by Piaget or Aurobindo, and this is the level we are in, from cognitive to higher mind. And if you look closer how this higher mind should look like, meaning in education, in society as a whole, these are examples that are going to happen, right? From cognition to cognitive endurance, to metacognition, to critical thinking, to pattern recognition. This is the toolbox. I cannot go with you through that toolbox now, but this is the toolbox you should not substitute by a machine. Cognition is replaced by a machine. Metacognition is not. What can we expect? We can expect something what I call a Renaissance 2.0. We can expect entering a phase where Socrates called 2,000 years ago the oral society, meaning we have to interact in an analog way, direct way between humans and humans. We can expect to enter a world where our consciousness becomes enlarged and more integral, and new values become relevant. And it's going to be a road to metacognition. And this is then where science and sapientia, science and wisdom, finally get together. Thank you very much.
Thank you so much, Stefan. Yes, perhaps we need to define what is value again. And sometimes what we are doing, scientists are doing, is not life-furthering, but life-destroying. Perhaps we need to write the code of conduct, ethical rules of not only science, but how to use AI. It is said that we can teach new things to new generations, but it's difficult to unlearn the things that we were taught before. So definitely we need new ways of thinking and values. Instead of domination, we need collaboration. Instead of, there is a famous saying, quality over quantity, produce more, earn more, consume more, produce more. Perhaps we need quality of all these things. And thank you for this inspirational speech. Now I'm going to give the floor to Professor Dr. Çetin Balanuye.
Thank you very much. Many thanks. Distinguished admins, dear colleagues, esteemed guests, and encompassing us all. I am positive about this, including all of us, our most valued students. Welcome. İstinye University Faculty of Medicine is once again offering us the opportunity to discuss a highly timely and vital agenda together. Our dear friend, Professor Dr. Türker Kılıç, is extending his surgical sensitivity, meticulousness, and discipline far beyond the operating table into life, into the street, and of course, daily life. And perhaps thanks to a neuroscience incentive award, right? Many thanks. We cannot thank him enough. Now, I was just told that, dear friends, the top title of this event is supposed to be, Is a Better World Possible? So I tried to figure out something such as on ontology, on ethics, on everyday life, and encounters. I think this is the magical word, encounters. So let me introduce with a misplaced question. The question, is a better world possible, is often asked with a certain ease, as if the problem were merely a matter of enacting better laws, finding sufficiently well-intentioned people, electing the right politicians, or choosing the correct moral principles. Yet, one of the most widespread experiences of our time is this. People often know very well what is good. Mostly they know what is good, and still find themselves unable to act accordingly. We are accustomed to explaining the failure by appealing to moral weakness, lack of awareness, or flaws of character. Today I would like to argue that this is a profound mistake. The problem is not that people are bad. The problem is that people are surrounded by conditions that do not allow them to accompany objective reality well. Of course, human beings are also not good either. I invite you to refuse all those old and wrong answers. And this is not primarily an ethical failure at all, but an ontological mismatch. For this reason, I propose to approach the question of a better world not as a normative wish, but as a question about what the world is, how reality moves. Of course, I'm talking about objective reality, and how we accompany that movement. The world is not a field of transcendent ends, but of units of power. One of the most deeply ingrained habits of our civilization is to conceive the world as a structure ordered towards purposes. The world is imagined as a stage designed to answer human demands for meaning. This habit appears in theological, progressive, and humanist forms alike, but it always rests on the same assumption. The world exists for something. Of course, inspired by Spinoza, my beloved philosopher, the ontology of power I have been developing for some time rejects this assumption outright. The world is not ordered according to transcendent ends. It's an immanent field of encounters. Many thanks. and interactions, of course, that necessarily move. The human being is not at the center of this field, but merely within it as one of its modes. In Netrons 1, I propose thinking reality as an ecosystem of IEEP. In Turkish, you know, call this, I just, come to call this as G varsa. It's a, funny word actually, but difficult but very explanatory. Entities that exist and real insofar as they express power. That is, insofar as they affect and are affected. To exist and to be real is nothing other than to express power. There is no supreme authority that decides what truly exists. Entities acquire reality to the extent that they affect one another in encounters. The list of realities available to human beings may partially overlap with the list available to a bat, yet neither list exhausts reality itself. A familiar illustration helps us. A bat's sonar-based world unfolds in the same cave as the human visual world, yet they do not accompany the same reality. Two beings may inhabit the same space without inhabiting the same world. This ontological framework radically transforms the idea of a better world. The question is no longer how the world can be redirected toward a better goal. The question becomes, within a reality, without an outside, how can we accompany objective reality with fewer illusions and sustain existence, however finitely, along joyful paths? If power plays such a central role, because I am always talking about power, we must clarify what is meant by it. Spinoza's ethics, I think one of the most interesting, most important, and most, lively, timely books ever written in literature. Spinoza's ethics can be read as a genealogy of power. Concepts such as power, potentia, conatus, desire, and expression all converge on movement and are consistently aligned with, pay attention here please, ethical notions such as virtue and wisdom. When I'm talking about power, I'm also talking about virtue and wisdom. So please, do not underestimate the importance of the concept of power. I'm not talking about, rough power, masculine power, physical power, including, of course, all these. But power means virtue, living virtuously. For a unit of existence, expressing adequate power in encounters doesn't mean defeating or annihilating others. On the contrary, antagonistic domination is itself a sign of weakness, of narrow-mindedness and ethical failure. A simple example makes this visible. Someone may win an argument and yet end up isolated, intellectually and affectively impoverished. By contrast, an encounter in which no one trumps, but both parties expand their capacity to think, constitutes a genuine increase in power in the Spinozist sense. As you may see, in this sense, the concept of power has nothing to do with Trump, for instance, Putin, for instance, Netanyahu, for instance. Power here is not control, it is the capacity to persist and expand through relations. This ontological framework has decisive ethical and political consequences. In Netrons 2, second of my series of books, I argued that ethics and politics still rely on a deeply flawed model of the human subject. The figure of the good person presupposes a conscious, rational agent who will act correctly once properly informed. Yet both philosophical reflection and contemporary science show that this model is untenable. Human action emerges largely from emotional, habitual, and environmental feedback loops. At this point, a strong resonance with contemporary neuroscience becomes visible. Over the past decades, brain research has increasingly abandoned the image of the brain as a centralized decision maker, instead emphasizing distributed, relational, and plastic process that, you know, a few hours ago, my dear friend, philosopher Kurtul was talking about plasticity and brain. Action doesn't originate in isolated moments of conscious choice, but in dynamics shaped by body, environment, and past encounters. Ethics that cannot be reduced to the art of making correct decisions. It must be understood as the practice of increasing encounters through active movement, and of accompanying these encounters with fewer illusions. Allow me a brief but necessary polemical note at the moment. We live amid an abundance of ethical appeals. Be more responsible, more sensitive, more just. Yet at the very moment these appeals multiply, inequality deepens, ecological destruction accelerates, and polarization becomes permanent. If morality is so important, why is it so ineffective? The answer is unsettlingly simple. The answer is unsettlingly simple, asking people to behave morally while leaving intact the conditions of poverty, insecurity, and constant threat that shape their lives is ontological naivety. Ethics is not about demanding heroism under bad conditions. Ethics is about transforming conditions. From this perspective, a better world is not one populated by morally superior individuals, but one structured by more active regimes of encounter. Activity must be carefully distinguished from speed or constant motion. In a Spinozist sense, activity involves an increase in power, but in the sense that I told before. Power in that sense, in the sense of virtue. The production of adequate knowledge and joyful movement. An encounter is active if it increases power, passive if it diminishes it. Here a crucial causal chain developed in neutrons too comes into play. Without increased movement, my dear friends, encounters cannot multiply. Without multiplied encounters, interactions remain impoverished. Without rich interactions, adequate knowledge of objective reality cannot develop. Without adequate knowledge, collective forms capable of accompanying reality well cannot emerge. This chain is not moral, it is ontological. A striking analogy clarifies the point. Expecting creative, cooperative, and reflective behavior from individuals trapped in an endless loop of work, depth, and exhaustion is like expecting physical strength from a body forbidden to move. Neoliberal capitalism. Here is the basic problem, actually. Neoliberal capitalism doesn't merely produce inequality. It does something more insidious. It systematically restricts capacities for movement, for motion, for creative motion. Chronic precarity, debt, insecurity, and poverty immobilize people not only materially but ontologically. Under such conditions, appeals to creativity, responsibility, or solidarity become detached from reality. This is the context in which proposals such as unconditional basic income, I'm sure most of you have already heard about this concept, unconditional basic income, should be reconsidered. Such proposals are often misunderstood as moral incentives or welfare schemes. Ontologically speaking, their primary function is different. They create thresholds that allow for encounters. Unconditional basic income doesn't make people good, but it can open a space, in which people become capable of entering active encounters with reality. Expecting social contribution from individuals deprived of existential security is like urging someone who cannot swim to cross open water. If ethics and politics are to be oriented toward building collectivities capable of producing active encounters, such structural instruments cannot be ignored. Okay, let me conclude. Let us return to the opening question. Is a better world possible? If by this we mean a harmonious, conflict-free, and perfected world, the answer is clear: no. Such a vision is ontologically groundless. But if the question is reformulated as follows: within this necessary reality, are more active, less illusory, and richer forms of life possible? Then the answer is cautious yet firm: yes. This possibility lies not in promises, but in practices, in the effort to align ontology, ethics, and politics with the dynamics of everyday life. Perhaps there is no better world awaiting us, but there are ways of accompanying this world better. Many thanks.
I'd like to thank Professor Balania for his extraordinary speech. And well, I'm very excited to be here and a part of this meeting here in between two very prominent people. And I would like to relay the microphone from a philosopher, a professor of philosophy, to a very prominent mathematician and a professor of mathematics from Boğaziçi University, Professor Betül Tanbay. Welcome, hocam.
Usually I hide my profession. I was going to say it at the end. Because the moment you say mathematics, you don't raise positive feelings in people, rather something scary that we won't understand. But actually, first of all, I apologize for coming late. I told Türker Hoca, for health reasons, I could only attend the end. First, I was regretting it a lot, but then I thought maybe it's better, because the more I listened to others, the more I had to say, and I had almost nothing to say, because almost everything was being said about all the issues and the worries that we have about the world these days. I don't have a slide, but Stefan gave me something, so I have one slide. And I will talk about this little square a little bit, so that we make it a little mathematics. But I've been working in Boğaziçi for 36 years now, even 37 almost. And when I heard Gary at the beginning talking about how disciplines were dispersed and then we are trying to get them together, and you talked about it too, I felt very bad about having been in all these years in a university which was famous for being a liberal arts college, where Fen and Edebiyat Fakültesi, the science and humanities, were together, and how in the last 5 years, abruptly and without the consent of anyone, it has been split into back. I mean, it's like we are going backwards while the world is going in another direction. I live in it, so I have to share it with you. Then I heard Şebnem talking about gender and the AI issues, where I had recently heard another colleague of yours, which you know, Mrs. Chopat, who worked in UNESCO and who talked about this. So this is another issue. It's true that all the improvements, especially in the last 50 years, that gender issues women obtained, is being kind of erased by the probabilistic approach of data. Because, of course, data and the machine has an information that is so big that our 50 years improvements is nothing towards it. So we are going to have only male figures when it's about pilots or doctors. So this is going to continue. So there are many issues that I found very, very exciting. But let me go back and be a little more personal, if you allow me. I've spent most of these 36 years without knowing Türker Hoca. And the first time I knew him is about 10 years ago, I think. A friend of mine sent me a YouTube of yours where he talked about connectivity. And his talk about connectivity, he gave an example, which I will come to Çetin's talk also, to Spinoza with it, because he was talking about an ortam, an atmosphere in 1600s. And he was showing slides. I mean, this is a brain surgeon who's talking about connectivity and who's talking about fundamental theorem of calculus, actually, which I'm teaching every year repeatedly. So he said, he was giving an example in Amsterdam about 17th century, 1650s, a few roads and blocks. Actually, what is very nice about Amsterdam is when you go there, you still have a feeling of what these roads were. Compared to Istanbul, when I arrived here, I had to spend half an hour between the two yerleşke, campus of H and E yerleşke. So our world is changing in a way where we leave no trace in this side of the world, unfortunately. But Amsterdam, you feel good about feeling this ambiance that Türker was talking about. And he was talking about family, Huygens family, where you certainly remember it. Huygens family, where the son, Huygens, who is going to be a great astrophysicist later, was not so good in math. So what do? I mean, the father is an eminent family in Amsterdam who says, let's give him some private lessons. And who's going to come for those private lessons? No one else than René Descartes. So he comes from Paris giving these lessons, and I always imagine, I mean, I added a little to your slide in between, because I imagine this huge table, I don't know, rosewood, something very heavy, and then there is this little Huygens, hardly up, and Descartes sitting there with all his majestuous way. And then there's a little guy next to Huygens, his schoolmate. Do you remember? Spinoza is there. He's a schoolmate, so he's also listening to Descartes. And these people later bring Huygens himself. So what Türker was saying, I think, and what I understood is that there is something there going on. And then I forgot about another guy who is just a few blocks away, who's painting Spinoza as a young boy, and that's Rembrandt. So this is quite amazing, and we are all very amazed by the Western culture, aren't we? But you said something about the East. Because during these years, 1640s, two people are born, 1643 and 1646, Isaac Newton in England and ich glaube nicht, Gottlob Leibniz. I suddenly have a Gottfried or Gottlob, I'm confused right now, but Leibniz is born. And they discover at the same time, and during those days, same times is about 20 years apart, but there is no internet, so they independently discovered what we call fundamental theorem of calculus. What is this theorem? It's something actually very simple. Something that people started when civilization started. I mean, people had to climb mountains and they had to measure and think about slope. And people had to plant things, so they had to measure the land. So there was the idea of area and the idea of slope, which is much older even than the writing, that where we start history, we say history starts with writing. Probably it started before, because people notice that they get tired when the slope is higher, yes? So that doesn't need to be written. You feel something different. So then years and years developed until some notions about limits arose. And then Newton and Leibniz, one in Germany, the other one in England, discovered that this notion of slope and this notion of area were related. Okay, first of all, a parenthesis. An AI would never guess that, okay? This correlation is not the capacity of the machine. This is human mind that can do it. I claim, and maybe it's a little ambitiously ignorant, but this is the way I feel. And one thing I would like to add about the East is, at the same time, someone else was born in 1643 in Japan. His name is Seiji Takakazu. And at the same time, he discovered the fundamental theorem of calculus. We don't talk about it because, me too, I am totally built up with the Western culture. And I start everything in Renaissance like most of us do. But things happen around the world at the same time, and incredible connections were made all throughout history. And people, when they start measuring, I will show my only slide. People, when they start measuring, I mean, it was very easy to think about a square, yes? A square is tempting because it's all equal. So if this is 1 and this is 1, wasn't it natural to ask yourself, how long is the diagonal, yes? How long is the diagonal? Okay, so now we all know that the diagonal is not one of those numbers we count. Like, it's not 1, it's not 2, it's not 3. It's something between 1 and 2, but it's not 1.5. So we know these 4 operations, and still we cannot reach the diagonal of this square. Okay, why? I think this has to do with exactly our problem today, is that what is this difference that Türker Hoca was trying to say about what is the difference between intelligence and the other word, zihin. I want to say zihin, mind, something else, and what is computable and what is not computable. So we call this diagonal, later we called it irrationals. So you get irrationals very easily. I mean, it's square root of 2, okay? You remember all Pythagoras' theorem? Yeah, it's square root of 2, but people spent hundreds of years to understand that square root of 2 was not a fraction. It was not a rational number. So this is the idea of limits that develops. So what are we trying? We are trying to understand the unknown, the unreachable, with the data, with what we have in hand, with the rational. So for me, to go from the rationals towards the irrational that we won't reach, and you're making all the brain network, all the connectivity, and you are discovering one thing every day. But maybe it's not so bad to think that we will not reach what we aim to reach, but we have to continue trying. So, and there, may I add to Stefan's a 6th insult. Yes, a 6th insult. How did you call it? 6th insult to civilization?
I only have 5. But we have
yes, I want to add the 6th. I will tell you this, and I'm not going to curse, don't worry. No.
Tell me the 6th one. I'm excited.
Yes, you are, and you should be. And it's interesting. For me, it's one of the biggest paradigm of thought change in the history of life. Yes. In the history of mathematics, certainly, but in the history of life, and it is interesting in terms of AI. We are in 1936. I'm not going to talk about Germany using these days, but people are leaving. Around the people who are leaving, there is someone called Kurt Gödel. And there is someone else called Alfred Tarski that you know less. You might have heard about Gödel, but you probably didn't hear about Alfred Tarski, who went to Berkeley, school where I went after, and for my PhD, and where he founded the group of Logic and the Methodology of Science. Tarski built that group between the mathematics and the philosophy departments. It is still a group that only gave PhDs, so it was an interdisciplinary group, as we thought about, of merging philosophy and mathematics. So here we are, as you said. And in the Tarski's group, exactly the questions of the main issue was what has been between 1900 and 1950 the main issue of mathematics. Everything that we think is true, can it be provable? So it's a big question about provability, which we also explain with computability, with definability. We have all these words on one side, and we have truth on the other side. truth is semantics, truth is meaning. And what is computable is data, is what you, coding, is what you can put in the machine. And the big question in 1900 in Paris, that when there was I think the first International Congress of Mathematicians was done, David Hilbert, who is also an eminent, very eminent German mathematician, he raised 23 questions, and one of them was the big Entscheidungsproblem. This was, the Entscheidungsproblem was exactly that everything we think is true, can we prove it? Can we have a machine where we plug in something and it will tell us, yes, this is true, no, this is false, okay? This was the big question. And there are people like Alonzo Church in 1929, Alfred Tarski in 1936, Gödel, who proved things that this is not doable. Okay, so this is not possible to have truth computed. Okay, these are very important results, and I think it's fully the fault of mathematicians that you don't know about it. Because a mathematician is unfortunately an isolated point who likes to gather 4 or 5 people, and when there are 6 people, it's already too much. And we have a blackboard and chalk, and we just want to know the theorem tonight, and we want to prove it, and it's our priority. And we really don't want to bother to tell about others about what's going on. I think I take the blame, because I think these days I really want mathematicians to be around to talk, and Türker is an exception who gives the opportunity to mathematicians to talk. I hope I didn't go over my time. 1 more minute, okay? And so to explain that, there is something called the Gödel's incompleteness theorem. And it says, and I think it's very important about pathways toward new civilizations, because we are right now in a world where everything we thought was universal is falling apart in big pieces. As now I'm talking here, we don't know how many more bombs have exploded very close to us in a neighbor country. So what was the United Nations? I mean, what was the human rights, the big declaration of human rights? What was universal? I mean, yesterday you hear the news that in my country, the courts do not have to listen to the Supreme Court. They don't care about the Supreme Court. So what kind of structure is this? With that kind of structure, where can we go? So in that, I think maybe we should go back to Gödel's incompleteness theorem. Why is it an insult? Because it gives the boundaries of human, what we can do and what we cannot do. It tells us that no matter which axiomatic theory we take, what is an axiomatic theory? Is we all agree that, I mean, when we say 1 or when we say 0, wherever we are in the world, we agree. I mean, you have never seen 1 going around. You have never met 2 walking around tables, but we all agree on what 2 is. We do not agree on what God is, or we do not agree on what belief is, on what good is and bad is, but we agree on 2. Isn't it amazing? Isn't it amazing that we have a tool that is universal, that we are using everywhere, every single moment, at every single data? Anything you do in coding is a new mathematical result. So we do all this, and we have a universal language. So in terms of mathematics, is really, I mean, there are big people who said it's the language of the nature. Yes, it is. But today, it's the most universal language. So let's see the limits of that language. This language says, okay, let's do some math together. Here are the languages. We put all our signs and we can write mathematics. Now, what are we going to accept and not try to prove? Well, let's accept that there are numbers. Let's accept that if there is 1, there is 2. If there is 2, there is 3. So let's accept that there is infinity, okay? We don't touch this. So we don't try to prove that infinity exists, we accept it. Now, these accepted things, we call them axioms, like the Constitution that we never have in this country. So we call them axioms, okay? So, and then from these axioms, we get new results. Gödel's incompleteness theorem tells you that no matter which axiomatic system you choose, the system itself will produce a sentence to which we cannot give an answer of it's provable or not. So this is something very important. Isn't it an insult?
Super. I have to incorporate that. We need to talk.
I'm not. No, I don't take it anymore.
Thank you, Professor, for this inspiring mind. I mean, your mind gives us hope for the future, the mind of a mathematician. And I would really like to thank... yeah.
You said mathematics and hope. Türker, can I say one more word? I invite you all this Friday on 13th of March to celebrate with us. I'm the chair of the International Day of Mathematics organized by UNESCO. And there is a webinar that we do on mathematics and hope. So let me do this publicity at the last moment. Just write UNESCO Day, International Day of Mathematics webinar. You will find the registration form.
Thank you so much. I would like to personally thank to Professor Türker Kılıç, who's, well, actually I'm proud of being his student from the medical school, and thank him for the opportunity he provided me to be here. And I would like to relay the floor. The floor is yours, sir. Thank you.
First, I would like to thank you all, and I would like to present you a brief summary of what I've been through during the last 15 years in my journey of neuroscience. And the slides are mostly in Turkish, so I would like to talk in Turkish, but sometimes I've switched into English in order to explain something more to you. Sizlere özellikle son 15-20 yılda beyin bilim alanında yaptıklarımızdan neler öğrendiğimizi anlatmaya çalışacağım. Ve bunların hepsini daha önce VAS'ın yayın organında toplamıştım. Burada en önemli noktalardan bir tanesi şu, bundan 15 yıl önce yola çıktığımız zaman esasında yaşamın yapı taşının atom olduğunu zannediyorduk. Birinci önermemiz, zaman içerisinde öğrendik ki yaşamın yapı taşı atom değil, enformasyon. The first argument is, one of the most important thing that we have been through is that the most fundamental thing in life is not the atoms, but the information itself. So, bu süre içerisinde birinci öğrendiğimiz şey perspektif her şey. Çünkü neye baktığınızı siz kendiniz belirliyorsunuz. Eğer yaşama şuradan bakıyorsanız, baktığınız ya da kafanızdaki zihninizdekiyle ilişkili olanı görüyorsunuz. Şuradan bakarsanız farklı bir şey, buradan bakarsanız daha farklı bir şey görüyorsunuz. Ve bu süre içerisinde bilimde önemli bir değişiklik meydana geldi. Hepimiz Newton, Bacon ve Descartes çocuklarıyız. Newton, Bacon ve Descartes çocukları olarak hep bir bilinmeze baktığımız zaman o bilinmezi parçalara ayırıp o parçalar üzerinde çalışıp o parçalarda elde ettiğimiz veriyi bütüne atfetmeye çalışıyoruz. Ve ilk olarak bu süreç içerisinde perspektifimiz insanlık tarihinde tümden gelim oldu. Yani bilim tarihindeki ilk yöntemimiz herhangi bir önermenin bütüne nasıl aktarılacağını konusunda anlamak şeklindeydi. Daha sonra tüme varıma ulaştık ve şimdi yeni bir metodoloji geliştiriyoruz. Bu yeni metodoloji daha çok bağlantısallık üzerine. Bu nedenle bugün buradaki herkesin üzerinde anlaştığı en önemli konulardan biri şu oldu. Bu bağlantısallık, yani connectivity bizim yaşam ilkelerimizi bağlayan temel unsur. Yani her şey içinde bulunduğu ağ ile anlamlı. Yani ne demek istiyorum? Mesela İsa'dan 450 sene önce Aristoteles çıkıyor. Diyor ki benim bir elimde 10 kilogramlık demir olsa, diğerinde 1 kilogramlık demir olsa, ikisini aynı anda yere bıraksam 10 kilogram olan yere önce çarpar. Ve insanoğlu bunu 2000 sene doğru kabul ediyor. Çünkü tümden gelimin iki önemli özelliği var. Biri kabulleniş, diğeri ise varsayım. Ne zamana kadar bunu doğru kabul ediyor? Ta ki Galile gerçekten Pisa Kulesi'nden 1 kilogramla 10 kilogramı yere bırakıyor ve Galile diyor ki 1610'da Aristoteles yanılabilir. Galile'nin Aristoteles yanılabilir dediği andan itibaren artık ağırlıkla kütle arasındaki farkı insanoğlu öğrenmeye başlıyor ve böylelikle herhangi bir varsayımın hipotez olarak kabul edilmesi ve bu hipotezin doğru ya da yanlışlığının yeteri kadar test edilmesi bizim bugün artık analiz ve sentez dediğimiz bilimsel yönteme yerini bırakıyor. Ve bugün artık yeni bir bilimsel yöntemle karşı karşıyayız. Bu bilimsel yöntemi biz beyin çalışmalarından öğrendik ve bu beyin çalışmalarından öğrendiğimiz veri bize yeni bir yaşam modellemesi sağlayabilme potansiyeline sahip. Bu nedenle bu toplantının esas konusu nasıl daha iyi ve güzel bir yaşam kurabiliriz sorusuna nörobilimcilerin verdiği bir yanıt var. Ve bugün dünyamıza baktığımız zaman görüyoruz ki mesela yaşam modellerinden bir tanesi işte özgürlük, eşitlik, kardeşlik. Bugün eskinin yıkıldığını biliyoruz ama yerine neyi koyacağımızı bilmiyoruz. Yerine neyi koyacağımızı araştırıyoruz. Ve nörobilim bize bu açıdan önemli bir imkan sağlıyor. Mesela bakın, gerçekten özgürlük var mı? Var mı? Çok yok gibi, değil mi? Peki eşitlik var mı? Yani tüm dünyada toplam gelirin aşağı yukarı %70'ini en üst %1'in elde ettiği düşünülürse çok öyle eşitlikten bahsedemeyiz. Kardeşlikten bahsedebilir miyiz? Yani bugün olup bitenleri düşündüğümüzde çok öyle kardeşliğin de olduğunu söyleyemeyiz. Peki bu içinden geçtiğimiz doğru olarak kabul edilenin gerçeklikle bağının koptuğu bu gerçeklik sonrası dönem artık yerini daha azgın bir sürece bıraktı. O da post-virtue, erdem sonrası dönem. Bakın bu erdem sonrası dönem post-truth'tan da daha tehlikeli. Çünkü bu dönemde doğru olarak kabul edilenin erdemle de ilişkisi kopmuş durumda. Bu nedenle artık yeni bir yaşam anlayışına, yeni bir yaşam modellemesine ihtiyacımız var. Ve bize bu konuyla ilişkili olarak ilk verileri John Wheeler esasında verdi. John Wheeler dedi ki bizim incelediğimizle gözlemimiz arasında bir bağ var. Halbuki Newton, Bacon, Descartes çocukları olarak bizler incelediğimizle gözlemcinin arasında bir bağ olmadığını kabul ediyorduk. Bu John Wheeler'ın çizimi ve John Wheeler ne zaman ki ortaya koydu kuantum düzeyinde de herhangi bir foton aynı zamanda dalga olarak da hareket eder. Neye göre? Gözlemciye göre. Yani her şey içinde bulunduğu ağ ile anlamlı. Gözlemlenenle gözlemleyen arasında bir bağ var. Ve işte bize bunu hayata aktarmada en fazla işe yarayan alan nörobilim oldu. Nörobilim bize dedi ki, bakın eğer biz parçadan bütüne gidersek, 1903'ten beri esasında bunu yapmaktayız. Nöronal doktrin bu demek. Ve bu ne zaman ki yapay zeka ile buluştu, beyin bilim karmaşıktan basite, yapay zeka ise basitten karmaşığa bir yöntemle ikisi birlikte artık bilinmeze daha yetkin bir şekilde bakabilme imkanı verdi. Bakın, en önemli slide belki de bu. Bunu bir mini beyin olarak düşünün. Bu mini beynin bize taşıdığı bilgi var. Bu bilgiyi biz hep daha önceden bu parçaları 12 nörondan oluştuğunu düşünelim bu mini beynin. Hep parçaları taşıyarak bu beynin bize ne anlattığını araştırıyorduk. Yani her bir nöronu araştırıp bunun diğerleriyle olan bağlantısını çok gözetmeden o nöronda elde ettiğimiz veriyi bütüne atfetmeye gayreti içerisindeydik. Oysa artık anladık ki esas olan bütünü oluşturan parçalar değil, bu parçaların birbiriyle olan ilişkisi. Yani esas olarak bu bağlantısallık bize bu bilgiyi sağlıyor. Ve biz bu parçalara baktığımız zaman her birine tek tek değil de onların birbiriyle oluşturduğu bağlantısallıklarına baktığımız zaman diyelim ki bu 12 tane nöronun ismi 3 tane kare, soyadı 4 tane üçgen ya da bağlı olduğu kurumda bu geometrik bir cisim olsun. Bu geometrik yapılar bize bu enformasyonu veriyor ve biz düşüncenin esasında nöronların birbiriyle olan etkileşiminin taşıdığı enformasyon olduğunu anladık. Ve böylelikle bu bağlantısallığın parçadan daha önemli olduğunu ve parçayı değil de bu parçaların birbiriyle yaptığı bağlantısallığı çalışmamız gerektiğini anladık. Bakın bu 2015'te yapılan bir deney. Bu deneyde hayvanın hipokampusunda kafesin kenarına konulmuş olan yiyeceğe gidip gitmeme kararını görüyorsunuz. Ve bu kararı verirken bu hayvanın 34.000 nöronunun ne şekil bir patern içerisinde olduğunu anladığımız zaman ve bunun bir matematik karşılığını bulduğumuz zaman, ki burada gördüğünüz bir animasyon değil, bir gerçeklik, bir video ve biz bu hayvanın az önce size hipotetik olarak gösterdiğim o üçgenler, dörtgenlerdeki bilgi taşıyan formülünün bir Bayezyen matematik sonucunda oluştuğunu fark edildi ve biz eğer bu formül içerisinde nerede olduğumuzu bilirsek, bu hayvanın kafesin kenarındaki yiyeceğe gidip gitmemediğini de artık bilir hale geldik. Yani ilk kez düşüncenin videosu, düşüncenin matematiği elde edilmiş oldu. Ama geride ne kadar var? Yani beyinde biliyorsunuz 100 milyar nöron var. 100 milyar eksi 34.000 daha var ki biz insan düşüncesinin nasıl bir zihin oluşturduğuna dair bir veri elde edebilelim. Bu süreç içerisinde tabii en önemli noktalardan biri bilinçlilik durumu. Stefan, I completely agree with you that consciousness is not found in the tissue of brain. So I'm seeing and handling at least 3 brains per day, and I haven't seen consciousness till now. So consciousness most probably is a kind of interaction between mind and life, because life itself is a context of information, and it is placed as a more complex type of information pattern, which is life. So the interaction of mind with life creates consciousness, and which is not located in the tissue of brain. But mind is a function of brain, and consciousness is a function of life which interacts with mind. So this is a kind of hypothesis that we are working on. Anyhow, sonuçta keşfettik ki böyle bir karmaşık sistem var ve biz bu karmaşık sistemin matematiği hakkında bilgi elde etmemiz lazım. Ve bu da bir animasyon değil, bu da bir görüntü. Bir nörona gelen ve giden bilgilerin görüntüsü. Yani her şey bir enformasyon. Ve biz bu enformasyon hakkında onun içinde bulunduğu kontekst içinde, yani bir patern, network içerisinde onun anlamı, meaning, anlamı hakkında bir fikir elde edebilirsek, o zaman bununla ilişkili esasında yeni bir yaşam modeli yaratmada fikir sahibi olacağız. Derken yıl 2018 oldu ve Giorgio Parisi gerçekten de o kuş sürüsü içerisindeki kuşların birbiriyle hareketinin nasıl bir bağlantısallık modeli yarattığını şu formülle ortaya koydu. Bu formül F eşittir MA gibi, E eşittir MC kare gibi sadece bize bir doğa olayını anlatan bir formül değil, aynı zamanda yeni bir kültür yaratma potansiyeline sahip önemde bir formül. Ve gerçekten de Giorgio Parisi bu buluşuyla 2021'de Nobel ödülünü aldı. Ve böylelikle biz anladık ki bu matematik formülü sadece kuşların nasıl kuş sürüsü oluşturduğunu bize anlatmıyor. Aynı zamanda evrenin her yerinde geçerli bir bağlantısallık formülü veriyor. So this formula is very important that Giorgio Parisi has and his group explored, because it doesn't only explains how this flock of birds form these patterns, and also it is valid in every place of the universe. For example, it explains how the cortex forms the thought, the pattern of thought, and also it is valid to understand the cosmic web when you look at through the most sophisticated telescope of Webb telescope. And also it is valid when, for example, iron and copper atoms come together and forms a new kind of compound. So these elements and atoms decides according to the formula of Giorgio Parisevs has explored and gained the Nobel Prize in 2021. Ve bu formülün esasında beyinde mesela beyinciğin kortekse benzeme miktarıyla korteksin kozmik web'e benzeme miktarı araştırıldı. Ve keşfedildi ki beyinciğin kortekse benzeme miktarı korteksin kozmik web'e benzeme miktarından daha az. Korteks kozmik web'e beyinciğin kendisine benzediğinden daha fazla benziyor. Ve bu patern oluşturma biçimi epileptik hastalarda da geçerli. Ya da söz gelimi 30.000 nükleotitli koronavirüs dediğimiz bir enformasyon sisteminin kendisinden 100.000 kat daha büyük bir enformasyon sistemine, insan hücresine girdiği zaman oluşturduğu farklılaşmanın sosyoekonomik alanda bir pandemi oluşturma ihtimalini bize açıklama açısından da önemli. Yani bu bağlantısallık matematiği sadece biyolojik olayları ya da beyindeki düşüncenin oluşumunu değil, evrenin her köşesindeki bir anlam yaratmada önem kazanıyor. So we learned that this formula is effective and is valid in every aspect of universe, and it can explain, for example, the epileptic fit, as well as it can explain the, for example, the teaching of language for a child's brain, for example. So, bundan sonraki soru, acaba bir yaşam modeli olarak bu bağlantısallığı biz kullanabilir miyiz? Ve yavaş yavaş yapay zeka geldi. Bizim ilk öğrendiğimiz şeylerden bir tanesi otopoiesis oldu. Otopoiesis, her bilgi işleyen sistem er ya da geç zeka üretiyor. So, one of the most important concepts of connectivity science is autopoiesis. Autopoiesis means every intelligence processing system in the end emerges to a different level and may create something different from its previous origin. Ve bunda önemli deneylerden birini size sunmak istiyorum. Bu bizim, en azından benim yapay zekaya bakışımı değiştiren bir deney oldu. Herhangi bir zeka üretildiğinde onu oluşturan sisteme, organizmadan bağımsız hale geliyor. Mesela bakın, bu bir deney solucanı. Bu deney solucanının bulunduğu akvaryumun kenarına glukoz koyuyorsunuz ve o glukoza gidip gitmeme kararını veriyor. Bunda sadece 383 nöron var. Birinci nöron, ikinci nöron, üçüncü nöron, birinci saniye, ikinci saniye, üçüncü saniyedeki makine dilini aktardığınız zaman basit bir robota, birazdan göreceksiniz, bu bir Duke Üniversitesi'nde yapılan bir çalışma. Robot bu. Çünkü sistem basit ve bu sistem artık bir solucanın içinde bulunduğu ağa göre tavır takınıyor. Solucanın yaptığı işi siz bu sisteme aktarabiliyorsunuz. So intelligence, once produced, does not belong to the organism that it is produced from. It belongs to the life itself. So in fact, there is no artificial or natural intelligence. There is only one intelligence which forms life. So as we are creatures that we are originating from anthropocentric culture, we consider everything belonging to the human being as natural, and something which is not produced by human brain as artificial intelligence. In fact, both of them are natural, and both of them belong to life itself. So, as we belong to anthropocentric culture, we create this artificial division between natural intelligence and artificial intelligence. In fact, when we consider or if we put life in our center of our mind, then it will be evident that there is only one kind of intelligence which belongs to life itself. So this is a kind of artificial separation that we produce. And after 2015'ten sonra bütün önemli ödüller hep enformasyon matematiğiyle çalışanlara verildi. Ve onlara hiç girmeyeceğim. Ama en sonunda geçen sene Michel Talleyrand, bir Fransız matematikçi, bu ödülü aldı. Michel Talleyrand'ın sorduğu soru şuydu. Mesela diyelim ki burada aşağı yukarı 500 kişiyiz. Bu 500 kişinin bir arada olma ihtimalini bundan 20 yıl önce, 30 yıl önce hesaplasak bu aşağı yukarı 1 bölü sonsuzdu. 1 bölü sonsuz sıfır demek değil. 1 bölü sonsuz sıfır demek olmadığı için biz şu anda bu gerçekliği yaşıyoruz. Yaşam dediğimiz şey 1 bölü sonsuzun gerçeklik bulduğu bir sahne. Nasıl? Nasıl? Bunun matematiği ne? Bunun matematiği. Michel Talleyrand bunu çalışıyor. Ben bunu kendime göre uydurdum da sorduğu soru şu. Mesela bu gökkuşağına baktığınız zaman şuradaki damlayla buradaki damla arasında bir bağlantı var mı? Var mı? Söyleyin. Evet var. Çünkü gökkuşağı var, değil mi? Eğer buradaki damlayla buradaki damla arasında bir bağlantı olmasa bu renkleri biz göremezdik. Peki soruyu şöyle soralım. Bu gökkuşağının ayağında şurada söz gelimi üniversite sınavına çalışan çocukla diğer ayağının altında bulunan fırındaki ekmek kokusu arasında bir bağ var mı? Muhakkak. Muhakkak. So everything is interconnected. This is just like this rainbow here. I can give this example. The water the water particle here in that part is evidently interconnected with the water particle here. Just like the person in the end of this rainbow is interconnected with the smell of the bread in the other corner of the island. So everything is interconnected. And this can be explained mathematically now, but our computers are not enough to conclude this. Bu nedenle de bir kuantum bilgisayar teknolojisine ihtiyacımız var. Bu kuantum bilgisayar teknolojisinin henüz ayak seslerini duyuyoruz. Bizim şu anda sahip olduğumuz bilgisayar sistemlerimiz henüz bize bu var olan matematik sistemleri anlatacak düzeyde değil. Ama biz yakın zamanda buna kavuşacağız. Dolayısıyla her şey içinde bulunduğu ağ ile anlamlı. So everything is meaningful in its context. Ve eski bilimle yeni bilim arasında bir fark var. Bu eski bilimle yeni bilim arasındaki farkın en önemli niteliği bu bağlantısal bütünlük, diğerindeki diyalektiğin önüne geçiyor. Ve artık bunun bir matematiği var. Bu matematiğin işte özellikli olanını buraya yazmıştım. Ve bir de beyin bilgisayar gibi çalışmıyor. Nöronlar her bir anda sıfır ya da birden birine karar vermiyor. Beyin sıfır ya da her hareketimizde her nöron sıfır ya da bir arasındaki sonsuz seçenekten birini seçiyor. Bu nedenle bütün bu öğrendiklerimiz ve nasıl ki Newton, Bacon, Descartes bilimi yeni bir kültür yarattıysa, reformu, Rönesans'ı oluşturduysa, şu an içinden geçtiğimiz bu bağlantısallık bilimi ve bunun matematiği bize yeni bir kültür oluşturma potansiyeline sahip. Biz bunu seçer miyiz, seçmez miyiz? Bu bize kalmış bir şey. Ama bu durum aynen bir yaprakla orman analojisini bize düşündürüyor. Bakın bizler içinde bulunduğumuz kültürde her birimiz farklı yapraklar olarak ormanın bizim için var olduğunu zannediyoruz. 1996'da Amerika'daki liselerdeki öğrencilere soruyorlar, kendinizi farklı hissediyor musunuz diye. Sadece %6'sı ben yanımdakinden farklıyım diyor. Aynı soruyu 2014'te soruyorlar. Öğrencilerin bu kez %96'sı ben tabii ki yanımdakinden çok farklıyım diye yanıt veriyor. Dolayısıyla bizler şu anda içinden geçtiğimiz bu kültürün çocukları olarak kendimizi yanımızdaki yapraktan çok farklıymışız gibi hissediyoruz. Ve ormanın da bu yaprak için olduğu zannıyla yaşıyoruz. Halbuki orman bu yaprak için değil, yaprak orman için. Ve buradaki en önemli yanılgılarımızdan biri ya da en büyük derdimiz ölüm diye bir derdimiz var. Çünkü bu yaprak kendisini yanındakinden çok farklı gördüğü ve ormanın da kendisi için yaratıldığı ya da var olduğu sahnesiyle yaşadığından günü gelip sararıp yere düşmesinin ormanın da yok oluşu olarak görüyor. Halbuki orman açısından bakıldığında yaprağın sararıp yere düşmesinin orman açısından sadece yeni bir doğuş olduğu belki anlaşılabilir. Dolayısıyla sona geldim. Biraz uzattım belki. Dolayısıyla bizim şu an var olan sistemimizde sistemimizde sahip olmak için çalışkan olmak, sahip olmak için zeki olmak gereğinden fazla kutsanmış hasletler gibi gözüküyor. Yani hepimiz sahip olmak üzerine kurulmuş bir dünyanın çocukları olarak varız. Oysa merakla başlayan ve sahip olmak amacını gütmeyen ama merakla başlayıp çalışkanlık ve zeki olmanın üzerine eklenmiş iyilik ve yaratıcılık üzerinden ilerleyen ve anlamlandırma ile sonuçlanan bir akıl yürütmeye ihtiyacımız var. Anlamlandırma bilinçle alakalı bir şey. So meaning is something related with consciousness. Bizler 5 duyu organımızla fark ediyoruz, beynimizle öğreniyoruz, zihnimizle zihnimizle anlıyoruz, bilincimizle anlamlandırıyoruz. Bunlar adım adım zihinden bilince doğru geçen aşamalar. Bütün bunları yapay zekacılarla birlikte nörobilimciler fark ettikçe anlaşılıyor ki artık farklı bir dünyaya doğru adım atıyoruz. Bu farklı dünya, bakın nasıl ki renk körü olanlar renk körü olduklarını bilmezler. Ta ki renk körlükleri düzeltilinceye kadar. Şimdi işte nörobilimciler ve yapay zekacılar yavaş yavaş bu renk körlüklerinin düzeltilmesi, antroposentrik bakış açılarının düzeltilmesiyle yaşam denilen o esas olgunun anlam sağlayan ünite olduğunu fark etmeye başlıyor. Bu önemli bir dönüşüm. Bakın nasıl daha iyi ve güzel bir dünya yaratabiliriz diye sorduğumuz zaman nasıl daha iyi ve güzel bir dünya yaratabilirimle konuya başlamamız lazım. Yaratabilirim. Esas iş bu. Ve bu bir dönüşüm, bir metamorfoz. Bu aynen tırtılın kelebek olması gibi bir süreç. Tırtılla kelebeğin gen yapısı aynı. Aralarındaki tek fark sadece genler arasındaki patern. Bu paternde bir farklılık var. Ben bu toplantıyı bundan 3 sene önce ilk kez Geri Jakobs'ta konuştuğumda amacım mümkün olduğu kadar öğrencilerime ve içinde bulunduğum ağa bu tırtıldan kelebeğe dönme sürecinde yardımcı olabilecek bir toplantı sunabilmek idi. Dilerim bunu başarmışızdır ve dilerim buraya geldiğinizden daha olgun şekilde bir tırtıldan kelebeğe dönüşme yolunda bu yeni perspektife kavuşmanızda yardımcı olan bir toplantı olmuştur. Hepinize teşekkür ederim.
Sevgili arkadaşlar, lütfen bekliyoruz. O closing remarks yapıldıktan sonra bitecek. Ve Ranoff hocamız konuşma yapacak.
Sevgili öğrencilerim, 5 dakika daha sabredin. Çünkü bu kapanış bölümünü yapacağız. 5 dakika sonra bitecek. Lütfen oturun.
Well, I'm glad you got a stretch, but I'm going to be short because, sometimes if you eat too much, you can get indigestion. And this was a big meal. I'm just going to go over a few things that were said today, just to refresh your recollection, so it'll stay with you. At the beginning was a discussion of synoptic systems thinking, the necessity for new paradigms, plasticity in our beings, adaptability, the precautionary principle in our relationship to the natural world, which I thought we came to the string instrument being able to play in harmony with the natural world, as well as the mystery of consciousness. The discussion about artificial intelligence, what are its dangers, what are its benefits, who's in charge of it, how do we stay in charge of it? The capacity of the artificial intelligence to create a deceptive world, a virtual world, and leading people to grow up without understanding what's real and what isn't. The hallucination of the machine and what will be able to determine it if people grow up without the capacity to distinguish. But I want to leave you with, and this is what I really wanted to do, why I just jumped up here. I did an outline of all of the talks that were given. But I think each of you got what you needed. One point. In order to tell the difference between sugar and salt, vision is not sufficient. Another sense is needed. In order to tell the difference between what is true and what is not, intellect is not sufficient. Wisdom is needed. Now, how is wisdom obtained, and how do we live with wisdom in a turbulent time? I come back to the wisdom of Mevlana Jalaluddin Rumi on this. He took the premise that the purpose of the human life is to fulfill this statement: I was a hidden treasure loving to be known. That's Allah speaking according to him. And that the purpose, the why of the human journey is to come to know the mystery that brought us here. And then it says in Quran, the one who knows themselves will know the Creator. So our entire journey is about coming to know ourself. The great Sufi Baba Muhayyiddin, who was my Sufi teacher, said, separate from yourself that which separates you from other lives. Anger, jealousy, pride, arrogance separate us. Love, compassion, patience bring us together, and they transform our consciousness into that perceptive device that can know why we were born. That's called wisdom. And this is what Rumi says about that. Listen to this. It's so short, but it's so perfect. It's a prayer that he made. Well, one time somebody asked him, what do you gain from prayer? And he said, I don't gain anything. I lose anger. I lose jealousy. I lose pettiness. I lose vanity. I lose fear. And then your natural state comes through. So he said, what was said to the rose to make it open, let that be said in our chests. What was said to the rose to make it open, let that be said here. And then he has some advice, and this is the advice I want to share with you in my closing. Because this is Rumi's advice of how to live in a turbulent time. He lived in a very turbulent time. He didn't start out in Konya, remember. He started out in what would be Afghanistan, and there was real chaos at the time. It was even more chaotic than today. And he had to travel by foot and donkey and horse to get here, to get to Turkey. So listen to what he says in the midst of a turbulent time. This being human is a guest house. Every morning comes a new arrival. A joy, a depression, a meanness, some momentary awareness comes as an unexpected visitor, something you didn't ever expect. Welcome and entertain them all, even if they're a crowd of sorrows that violently sweep your house and empty it of its furniture. Still, treat each moment, treat each guest honorably. It may be cleaning you out for some new delight. You never know. The dark thought, shame, malice, meet them all, but with laughing, and invite them in. That transforms them. But be this, for whatever comes, be grateful, because each has been sent as a guide, if you know, from the beyond. Thank you.
Bir fotoğraf çekeceğiz. Lütfen isteyen herkes sahneye gelsin. Çocuklar.